Hello, Algebra 1. Today we're looking at lesson 3.2, solving systems of linear equations by graphing. And class, this is our first exposure to solving systems. And part of that, you can look at our objectives there. We are going to check if check if something is a solution of a linear system. We're going to solve them by graphing, and then we'll also look at a real-world application. So what you have is an example of a system right here. They often stack them when they're given to you. I personally always split them up. It gives you more room to work. It makes more sense, I think, for working. But they usually give them to you stacked. If they don't give them to you stacked, there might be like a semicolon in between them or something like that. But anyway, here's the thing. This line right here, this equation, I should say, has infinite solutions. There's more than a million possible XY combinations that solve this equation, that satisfy that equation. And that's why it's a line when you graph it, because it goes on forever. Well, to be a solution of a system of equations, you have to be a solution for this equation and this one at the same time. Now remember, this is a line as well. So you've got a line, you've got a line. You need a point that satisfies both of them at the same time. So for our first examples here, we're just going to be seeing if a XY value is a solution to both equations, okay? So it says, tell whether the ordered pair is a solution of the system of linear equations. I don't like that they put these little lines through there because it looks like division. It looks like something out of Algebra 2. But anyway, there's our first equation. There's our second equation. You have to check both of them to see if it works. So be really careful when you substitute in. And then once you get it substituted in, oftentimes you can do the rest in your head. 2 plus 5 is 7. You get 7 equals 7, so that checks out. That is a solution to the top equation, but that's not good enough. You got to be a solution for both, so you got to try that out as well. And again, carefully substitute in the 2 for the x, the 5 for the y. And then I'm going to do this in my head. You're going to multiply first. Order of operations says to do that before the subtraction. So we multiply first. We get 4 and 15. And 4 minus 15 is, in fact, negative 11. So this worked for both equations. So that means that... yes, it was a solution. This was a solution to the system. Okay, let's try the next one. So carefully put negative 2, put 0 in for y, negative 2 in for x. And then you might be able to do the rest in your head. Negative 2 times negative 2 is positive 4, minus 4 is 0. It checks out. But you got to check both, because if it's not a solution to both, it's not a solution to the system. So let's put 0 in for y down here, negative 2 in for x. And I'm seeing pretty clearly here, this is not going to be a solution of the system, because this is not true. So our answer is no. Negative 2, 0 is not a solution to that system of equations. Oh, I should mention, systems of equations are kind of interesting because we're in Algebra 1, we just learned how to solve like 2, maybe 3 equations at the same time. But in Algebra 2 and above, you start learning that you can have lots and lots of equations. And that inspired matrices. You probably heard of The Matrix, those awesome movies that were made in the 90s. But yeah, a matrix is basically a bunch. It's a large system of equations, which is kind of cool. Once you have a bunch of equations, you get to learn some other methods for solving other than the ones that we're going to learn. So yeah, it's kind of, we're just at the tip of the iceberg here as far as systems of equations go. Well, our example 2, solving a system of a linear equation by graphing. Yeah, so we're actually going to solve today. So like I was saying, there's infinite answers for this, and that's why it graphs a line. There's infinite answers for this. That's why it graphs a line. Well, if you graph them, let's see what happens. So on this first one, the slope is -2/1. The y-intercept's 5. We can graph that right away. Dot at 5, down 2/1, down 2/1, down 2/1, down 2/1, down 2/1. I'm going to keep going. And then we'll use, we'll go back, we'll go up 2, back 1, up 2, back 1. And we will connect our dots to get our equation here. Okay. So that is the graph of all the solutions for this equation. Now we're going to graph this line, which will be all the solutions for that equation. And let's see what happens. So our y-intercept, our m is 4/1, our y-intercept is -1. So our slope tells us to go up 4/1. Now check that out, up 4/1. I'm going to stop right there because I found where these lines intersect. Now let's think about that for a second. If we are standing on that intersection point, we are standing on both lines. What that means is that coordinate is a solution to both equations. And what's special is it's the only possible solution that works for both. It's the only place where they overlap. So that is going to be our answer to both of these equations at the same time. It's going to be 1, 3. And you could totally, I'm going to go ahead and box it in because I feel so confident. But what if we messed up the graphing? What if we forgot a negative? I know a lot of us tend to do that. But yeah, so what if we forgot a negative? What if we graphed it wrong? I'd kind of like to know if this is in fact a solution. So I'm going to check. And I'm going to do a little bit of a quick check here. So 1 here would get me a -2 + 5. A 3 here. And sure enough, that checks out. A 1 here will get me 4 -1. A 3 here, and by golly, it checks out. So it was a solution to both equations. So our answer is 1, 3. We commonly write our solutions as an ordered pair. If you're in a word problem, you're probably not going to write it as an ordered pair because, you know, 1 hot dog and 3 hamburgers doesn't really make sense as an ordered pair, in my opinion. But anyway, we commonly write them as ordered pairs. Okay, let's flip it over and try another one. So we could solve both of these by finding the x-intercept and the y-intercept, but it does suggest, hey, solve for y first. I think that's a good idea. But I just wanted to point out, you could solve these by using x and y intercepts. It's a pretty quick way to do it. The x-intercept would be 2.5. The y-intercept would be 5. The x-intercept would be 1 1/3. The y-intercept would be -2. You could graph these by using intercepts, but it turns out if you got the slope, your slopes often overlap, and you can find your answer right away, which is cool. So on this this one right here, I'm gonna just rewrite this side by side. So I just rewrote it. But to get y by itself on this one, that's pretty slick. We're done real quick. Our slope is gonna be 5. I'm sorry, our y-intercept's 5, and then we go down 2/1, down 2/1, down 2/1, down 2/1, down 2/1, down 2/1. and draw that line. Again, that's all the solutions for that equation, graphed. And then we also want to get y by itself on here, so subtract the 3x over is what I would do. And then we divide everything by a -2. And our y-intercept's -2, our slope's up 3 over 2. And oh my goodness, look at that. We're already there, up 3 over 2. We've already found the intersection because our slopes overlapped, which is nice. It's nice. All right, so where do they overlap? That's going to be the solution to the system at 2, 1. And you can totally check. I would check in the original problems, not the ones you rewrote because you might have made a mistake. But you could check up there and quickly realize 4 plus 1 is 5. That works there. 6 minus 2 is 4. It works there. That's our solution. Okay, next up, we're going to look at an application problem. It says a roofing contractor buys 30 bundles of shingles and 4 rolls of roofing paper for $1,040. In a second purchase at the same price, the contractor buys 8 bundles of shingles for $256. Okay, so class, they're wanting us to find the price per bundle of shingles and the price per roll of roofing paper. So we know 30 bundles, 4 rolls is that much. We know 8 bundles is that much. But our unknowns are the price for shingles, for a bundle of shingles, and the price for a roll of roofing paper. So I just arbitrarily decided to make X the shingle one, Y the roofing one. And that matches with what they have here. I already know and realize that. But so that's good. But we've got 2 equations here. We don't know, and we've got 2 unknowns. And that's common. You usually have as many unknowns as you have equations. It's kind of interesting. But yeah, so I'm going to write an equation for this first purchase. There was 30 bundles of shingles, but we don't know how much they cost. But we're going to multiply by the cost per bundle. We're going to add to that 4 rolls, but we don't know the cost of the roofing rolls of roofing paper, so we'll call that Y. But that together needs to equal 1,040. Our other equation is going to be, just 8 bundles of shingles for $856. So here I am stacking them, and I don't like to do that, but I'm just going to give myself a little bit of space. So 8y equals 256. That's my 2 equations. So this is a system. But class, I'm willing to bet some of you are looking at this and saying, you know what? I can find y right away. And you're totally right. You could get y right away. And then you could then solve for x. And so you could do this algebraically. I have confidence that you guys could do that. But you know what? We're into the graphing section, so we're going to graph this thing. I'm going to graph this by using intercepts up here. The x-intercept, the y-intercept, but the x-intercept is going to be 1,040 divided by 30. And I get 34 2/3. 34 2/3. My y-intercept ends up being 260. When this becomes 0, divide by 4, I get 260. So I'm going to plot those points. So 34, that's going to be a little over halfway there, a little over halfway. 260, that's going to be smack dab in the middle between 240 and 280. And I'm going to connect them. And that's going to be all the solutions for that equation. They're all on there. For our other equation, we need to get y by itself because I'm going to realize that oh, you know what? I think I may have worked this out wrong earlier in class today. That's kind of unfortunate. But yeah, I think maybe, let's see. So shingles. Oh, okay. I'm gonna catch it. I made the mistake here actually. I said that it was 8 roofing paper, but it's 8 bundles of shingles. So I need to change my equation here. It's not a y. We're not talking about the roofing paper. We're talking about the shingles here. So I need to change that variable to x because we were talking about shingles up there, and I made the price per bundle of shingles x. Now I'm back on track. So I did make a mistake on this lesson. I was about to make a pretty dire mistake, but I think I'm back on track. Okay, so divide by 8. We're going to get x by itself. Now, the reason I did that is because I know how to graph this. This is going to be a vertical line because it's just x. A vertical line at x is equal to 32. And our solution is going to be where these graphs intersect, and it's right there. Now class, here's the downside of solving these by graphing, is that if where they intersect doesn't hit perfectly on a grid mark, you have to guess or estimate what the answer is. I'm going to guess that I know my x is 32, so that's going to be $32 for the bundle of shingles. I found that right away. But the corresponding y value appears to be halfway between 0 and 40. So I'm pretty sure it's going to be 20 for a roll of paper, roofing paper. I'm pretty sure about that, and I can test it by going up here and putting 32 in and 20 in, and I'll let you guys know that you get 960 and 80, and those add together to make 1,040. So we got our answer right there. Sweet. So yeah, have a good day.